Assalamu alaikum warahmatullahi wabarakatuh. I hope you are enjoying this course. So we already make a lot of introduction in our course Microcontrolling Start as Professional. This is me again, Muhammad Hayyan Al-Sbai, and today I'm going to start with module 4, which is Introduction to AVR Microcontroller. So today we speak about the microcontrollers in more details. Previously we speak only about the concepts and the materials that are used inside the microcontroller. So today we are speaking about the microcontroller. By the end of module 4 part 1, you are going to understand what is embedded system and get introduced what is the AVR family, which is the microcontroller that we are going to use in this course. Last time we spoke about the integration, we speak about the gates, we speak about the binary numbers. So gates are integrated from transistors, then the microcontroller is integrated from the gates. So we have microcontroller and microprocessor are considered as a very large scale integration. We speak about the programming. So microcontroller actually is a programmable device, a device that we can be programmed. It's made of gates, and to program it we use the program memory. So we put the code inside 1 and 0, and this will connect the gates to make our programs. We're not going to speak a lot of details about this one, just to understand the concept, what is the program is really doing when we write it. So now let us speak about the microcontroller and the embedded system. What are the embedded systems? So an embedded system is a special purpose computer system designed to perform one or few dedicated functions, often with real time. So you remember we make a small introduction about computers in general. So we say that microcontroller is one of the computers. Microcontroller is actually a complete computer. So when we speak about embedded system, it's a special purpose computer. It's an integrated device which consists of multiple devices like microprocessor. The microprocessor, you already, I think everybody know what is the microprocessor. We speak about them also. It also include memory, input-output ports, and often has its own dedicated software. So the embedded system is actually a complete computer. It's one chip, one integrated circuit, and this integrated circuit is having all these devices: microprocessor, memory, input-output, and ports. So just to remember, the microcontroller is a microprocessor plus peripherals and plus memory. Now speaking about the microcontroller, we need to introduce a concept called instruction set architecture. So a microcontroller is a programmable device, so there is an instruction or program to write the program. Also we need to understand the structure of the microcontroller. So this is what we are going to do in this module. So the instruction set architecture in general is an abstract model. So like we make an abstract, a model, modeling the computer that defines everything a machine language programmer needs to know in order to write machine language program for that computer. When we write a computer program, we're actually writing an instruction to the processor. So it's also referred as architecture or computer architecture. So basically when we speak about ISA, we speak about the memory models, the registers, the data types, and the instructions. So there are different types of instructions for microcontrollers. One of them is called CISC, or a complex instruction set computer. It has many specialized instructions, some of which may only be rarely used practically in practical programs. We have what's called the RISC, which stands for a reduced instruction set computer. Simplifies the processor by efficiently implemented only the instructions that are frequently used in programs, while the less common operations are implemented as subroutines. So these two concepts are available in different microcontrollers. So actually when we speak about microcontroller, there is a lot of families and a lot of devices which can be considered as microcontroller. So we have Altera, AVR, Korn, Epson, Intel, NEC, Toshiba, Texas Instruments, and so on. Many of these families or like corporations make microcontrollers. We are going to speak about the AVR, which is manufactured by Atmega. So why we choose AVR? Actually, in this course, we link it with Arduino. So Arduino is very popular, and AVR family is used in Arduino. It's RISC architecture. So RISC architecture is a reduced instruction, so no need to layer many instructions, so it's easier to understand. It has a wide variety of on-chip peripherals. It has digital input-output, ADC, analog to digital converter. It has timers. It has serial communication, which is called UART, and it has the function of pulse width modulator. So besides it's basic as microcontroller, it has a lot of devices, useful devices. There are two main types of architecture for microcontrollers. One is called the von Neumann model, and the other is called the Harvard model. So AVR actually is Harvard model. It has a control unit, it has instruction memory, so there is separate memory for program. The control unit is connected with the ALU, the microprocessor. There is the data memory and I/O. The difference from von Neumann model, it has there's no separate instruction besides to the other strings. Speaking about ISA, we need to understand the memory. So there are 4 types of memories in Atmel AVR. Okay, so one memory is dedicated for the program. So we have the program flash memory. The other memory is data memory. It consists of register, I/O registers, input-output registers, and SRAM. We have what's called the EEPROM, and we have the fuse bits. We'll speak about them in details. Okay, so today we just introduce what is AVR. Okay, so you need to understand this structure to understand how to write a program to make controlling. Now, everything is 1 and 0. So when we save things inside the memory, we save 1 and 0. We need to put read and write data using what's called the data register. There is what's called the address register to decide which bulk of memory we are going to write in. So the two main memory operations are called read and write. A simplified read operation is shown in which new data overrides the original data. Data moves to the memory in several steps. So first we decide the address, then we decide the data to be put in the memory, and then the control unit is giving the write. Okay, so you remember we have inside the CPU there is the control unit. This is decide read or write. We have the address bus and the data bus. Okay, so this is the operation for read. So put the address, make write, that means the direction from data register to memory. When we want to read from the memory, so the direction is, as you see, from memory to data register, and from the address will decide which memory to read from. Okay, so the operation is the address is placed on the address bus, a read command is issued, a copy of the data is placed in the data bus and shifted into the data register. Okay, so as I said, we are studying the ISA. ISA is, we need to understand the memory models, the registers, the data type, and the instruction. So now we are speaking about the memory models. Just introduce the memory models of the microcontroller. When we start to write the programs, if you feel like you don't understand, it's normal, no problem. When we start to write the program, you will stand to understand how to use these things. So now just take it as it is and understand what type of memory our microcontroller is using. Okay? So Arduino Uno is very popular, and Arduino Uno is using the microcontroller from AVR family. One of the AVR family is called Atmega 328. So this is the plastic dual inline package. So this is the type of this package is called plastic dual inline package. What do we mean by plastic? It's made of plastic. Dual inline, so we have 2 lines of pins. So this is our microcontroller. We will use a software to write a program. Then we will upload this program to its memory. This memory will open the gates to make the program working. We will focus also around another microcontroller which is easier to understand, which is Atmega 32. Again, this is the package of plastic dual inline. So, and these are the pins. Actually, in this course, we are going to understand these pins one by one and how to use them, how to use what's called the register as part of the memory to control the microcontroller, and how to do a lot of functions using it. Okay? Actually, this is not the only packaging way of this integrated circuit. There are different types of integrating circuits. So the package is the shape of the microcontroller. So as you see, we have what's called the quad flat package. So some of the, if you are familiar with Arduino, some of them is using this package also. Now, speaking about the structure, as we said, we are still talking about the memory. So this is the structure of our microcontroller. So this is the basic of it, which is ALU, the processing unit. It's connected to what's called as general purpose registers. We'll speak about them later. There is what's called the status and control registers and other things. There are some devices, and there's the data bus. You remember, we speak about all of this when we introduce the computer. Then we have this important part, which is actually the program memory. So the program memory is this memory. Also, we have instruction registers, we have instruction decoder, and the program counter. The program counter is going through the memory one by one to know where my program is executing now. So a program counter is a register structure that contains the address pointer value of the current instruction. So to read from the memory, we need the address. So the address is stored in the program counter. So this is all for today. Just a quick introduction. What is the AVR family? Thank you for listening, and here are some references. You can refer to them. I hope it's not very complicated for you. And don't worry if you don't understand, because it's just like we're giving a lot of concepts. Then when we start using this concept, you will understand this concept better and better. Thank you for listening.